So yesterday we either knew one of the variables when we started, or we already had one equation that had two variables. We just had to find another equation with only two variables so that we could solve by elimination. So we are going to do the same thing. We still need two equations with only two variables. So underneath this, I will eventually write two equations that only have two variables. Now, yesterday we kind of were able to just think about, okay, what next? What do we need to do next to get what we need? But when you start with three equations with three variables, you can't just think about the next step. You have to think about the next two steps. So we need to eliminate one variable twice. We need two equations where the same variable has been eliminated. So we could say this first equation and the second equation, it's got negative y and positive y. We could easily take these top two equations and eliminate y. But then we'd have to eliminate y again. So then we would probably take the top equation and the bottom equation. We'd have to multiply the top equation by 3 so that we'd have negative 3y and positive 3y. So that would be one way to do this. Eliminate the top two, then multiply the top one by 3 and eliminate the top and the bottom. We'd eliminate y twice. Or we could look at the z's. Do you see how we have 2z, negative 4z, and negative 4z? We could multiply the top equation by 2 to make this be 4z. Then we could eliminate the top two and then eliminate the top and the bottom. So there are two options here. We have two different ways that we could solve this particular problem. It is up to us how we want to do this. You may choose to eliminate the y's. Your neighbor may choose to eliminate the z's. Ultimately, you will both get to the same answer in the end. Your work will just look different. So do you all have a preference? I'm going to go for y's if you don't have a preference. Okay, so if I eliminate the y's, first I'm going to take this top equation and the middle equation, and I am going to take the time to rewrite them. I think it's important to rewrite them so that we definitely don't make any mistakes and can really see what we're doing. Okay, these are perfectly set up for the y's to eliminate. We have 4x minus 2z equals negative 10. And I'll put that equation up here. 4x minus 2z equals negative 10. Now we're basically at the stage that we were yesterday. We have one equation with two variables. We need another equation with just x and z. So this time I'm going to take the top equation and the bottom equation and eliminate the y's again. This time I have negative y and 3y, so we need to multiply the top equation by 3. That would give us 3x minus 3y plus 6z equals negative 12. That equal sign looks funny. And on the bottom, 2x plus 3y minus 4z equals 4. My y's eliminate, which is what we were trying to get, plus 2z equals negative 8. Bring that one up here and put it with our other two variable equation. And you might start to see how I organize my work. Do you see how on the left, everything on the left has three variables? And now I'm moving into like the middle where I'm going to have two variables, and then I'll use this space on the right to finish. So I try to organize my work into 3 columns just to keep everything nice and organized. And if you're just doing things randomly here and there and everywhere, it can be very difficult to follow your work. Okay, now we need to eliminate with these two equations that only have two variables. The nice thing is, what do you see right here? It's already perfectly set up to eliminate the z's. What if it wasn't? What if this was negative 2z and 5z? We would have to multiply one or both of the equations to get them ready for elimination. So you may have more work to do here in this elimination. In this one, it is perfectly set up already for us. So 4x and 5x is 9x. The z's eliminate. Negative 18. So what does x equal? Negative 2. So we know that x is negative 2. Now this problem becomes like the first problem we did yesterday. We have one variable, we have to back substitute to figure out the rest of them. So I am going to choose one of these two, either the purple or the green equation. Which would you prefer I pick, purple or green? Purple? Okay, purple. 4x minus 2z equals negative 10. I'm going to plug this negative 2 into the x. 4 times negative 2 is negative 8. I would add 8 to both sides. Negative 2z equals negative 2, so z is 1. Now I need to go back and pick one of my original equations. And sometimes it's very obvious which one you should pick because sometimes one of them is like all positives or all super small numbers. This one is pretty evenly, like they all have something that's kind of crappy about them. So I'm just going to pick the top one. And again, I always rewrite the equation so that I really know what I'm plugging things into. X is negative 2, so negative 2 minus y, we don't know why. Z is 1, so 2 times 1 is 2. The negative 2 and the 2 will cancel each other out. We have negative y equals negative 4, which means that y is 4. Keep in mind, how you decide to attack the problem may be different from how somebody else decides to attack the problem. So your work may end up looking a little bit different depending on what strategy, which variable you attacked first. Try to keep your work as organized as possible. Today you have a worksheet, 5 problems. Some of them, like 2 of them are back substitution. They should be pretty quick and easy. 2 of them are kind of like we did yesterday, and then only 1 of them is a true 3 variables in all 3 equations like this problem.